Hey folks, welcome back one more time to our last lesson in section 5.1 in our CPM ebook. Today we're going to talk about and formalize a pattern in section 5.1.3, and the pattern I'm going to tie to a very reasonable thing with reasonable experience that most of us have, and it's going to go back to what we talked about in our prior lesson 5.1.2. So if you haven't done the work there, you're going to want to go back and do that in order to make sure most of what we talk about today, or in this unit, this lesson, is as digestible as possible. The goal, we're going to start with 528. We're going to again refer to that rebound ratio, but I'm going to refer to that rebound ratio and I'm going to look at some data that is going to pull not necessarily just from drop height and start height, drop height and rebound height. I'm going to look at a couple different variables here: drop height and bounce number, or rebound height and bounce number. And so on and so forth. We'll again use the idea of the bouncy ball from 5.1.2. And if we had the opportunity to do this in class, I would have you guys collecting this data on your own. But just due to the nature of the pandemic, we don't have that opportunity. So I'm going to start with this video. The video, admittedly, is not super duper, does not have super duper high production value, but it gets the point across here. So make sure you can see what's going on. Make sure you can hear.
As we release the ball, it falls and bounces and goes up to a decent height. You can just see the shadow there of where it goes. It's going to now do another bounce moving down, and then it bounces, squashes, and now it rises to about 3/4 of the height, and then it continues to fall, and we can leave it to bounce quite happily to the end.
All right. Couple things about the video. I think you guys saw the gentleman who was making the video drop the ball, and then it bounced, and he said a couple things. One notable item was an item that we're going to use from yesterday, or from the last lesson, which was that ball bounces back to about 3/4 of the height. Remember, our rebound ratio for the bouncy ball was 0.75. 0.75 and 3/4 and 75%. Those are all equivalent representations of the exact same number. So that's important. And then one of the things I hope you saw, and I hope this aligns with your experience, if not, go grab a ball from somewhere in your home, but drop it and then don't put any more energy on it. Don't dribble it. Just let it drop, and it's going to bounce. And that bounce will start to deaden. It will diminish over time. And that is the pattern that we want to look at today. All right? And we're going to start by like I said, examining some of that knowledge from yesterday, okay? And we saw this in the video, and we did this in our work from section 5.1.2. The rebound ratio was 0.75. That's what part A is asking me here. 3/4 or 75%, all equivalent ways to think of that. And then, as you saw in the video, and as we discussed yesterday, the rebound ratio was not affected by how high we dropped that, right? Yesterday we had that linear model that told us no matter how high we dropped that ball from, it was always going to come back to 3/4. We saw that in the slope triangle yesterday. We saw that by the fact that it passes through 0, 0. If we had the opportunity to test this in class, this would be far more powerful. But if you don't believe me, test it at home. You'll have to use a measurement device. Maybe it's a video, maybe it's a yardstick. I'm not sure, but whatever is convenient for you, you're going to find that the rebound ratio is not impacted by the drop height, right? And that's what part B is, okay? And then part C is actually pretty important because it's going to help us start to formalize this in terms of an equation. Part C says if you were to use the same ball again, drop it from any height that you wanted, could you predict the rebound height? And the answer is yeah. We could always take that rebound ratio, multiply it by whatever our drop height is, and that's going to give us our rebound height. And that will work 100% of the time, okay? Rebound ratio here is 0.75 because we used a bouncy ball. If it was a basketball, it'd be different. If it was a golf ball, it'd be different. If it was a bowling ball, it would be different, right? But this is specific to our bouncy ball. And now we're going to go ahead and we're gonna take this and we're gonna put it into a model, and we're gonna see how this kind of creates a new pattern and a different graph that maybe we've never seen before. Okay, moving on to 5-29, it says, imagine you drop the ball from a height of 200 centimeters, but this time you let it bounce repeatedly, just like the guy did in the video. Okay, and if you need to, back up and watch that video. Discuss this situation and sketch a picture showing what this situation would look like. Your sketch should show a minimum of 6 bounces, okay? Now I'm going to do my best here, and I'm going to try to draw this out. Normally, you know, the one you saw in the video, the ball kind of bounced up and down in the exact same spot. I'm going to draw mine out, okay? So watch what happens here, and I'm going to see if I can start to kind of generate some thoughts about this for you, okay? We drop from, you know, let's say here, okay? And the ball would bounce. Oops, I don't want it to be a straight line. The ball would bounce, and then it would come back up to about 3/4, and then it would go back down and bounce again, and it come back up to about 3/4, go back down and bounce again, come back up to 3/4, and this ball would keep bouncing and bouncing and bouncing and bouncing, okay? Until ultimately what happens. We'll talk about that in a second. But, ladies and gentlemen, if I was to consider the peak height, the peak rebound height, I'd see something happen, which I think we might see in a little bit here. And then, right? Okay, but what do you notice? We see that bounce diminishing over time, and look at what I've got in red here, and now let me get rid of what I got in blue. Oh, shoot, I can't do that. It's not going to let me get rid of all that at once. Dang it, I can't do that. But look what I have there. It's not going to necessarily paint the exact same picture if I get rid of those bounces. So how can we do that? Well, we can take and we can start to make some predictions using a little bit of math. And what I'm going to use is, of course, my handy dandy phone calculator. So if you got one of these, go ahead and get it out. Open up your calculator app. Otherwise, your Chromebook's got one of these. Or if you got a handy 4-function calculator laying around the home, that will work out really, really well for you. But anyway, it says part B says predict the ball's rebound height after each successive bounce. If it starts at 200 centimeters, create the table with these predicted heights. So here's what we got going on. I made a table, and I've got bounce numbers 0 through 6, right? Because the previous question said, hey, do this through 6 bounces. And I'm just going to go ahead and take that bounce height, just like we talked about up here, and I'm going to multiply it by 75% or 0.75. And that's going to give me the rebound height. So I start with 200 centimeters in my calc, 200 multiplied by 0.75, and that's going to give me that rebound height. And that rebound height is simply 150. Now, we're not going to interrupt that ball bouncing. It's going to come back up to 150 centimeters, and it's going to go down for another bounce. So I'm going to take that 150, and I'm going to multiply by 0.75. Now, the calculator says that's 112.5. And I'll tolerate the decimals right now. It's not going to hurt me to do so. I'm going to continue. I'm going to leave that 112.5 in there. I'm going to multiply by 0.75, and that gives me 84.375. Okay, I'm going to keep going here. I'm going to multiply that by 0.75. And now my decimals are starting to get a little long, so 63.3, and that's approximate, right? It's not exact, but it's approximate. I'll now multiply by 0.75, and then, ooh, yowza, 47.5, and again, that is approximate. It's not exact. And one more time, 0.75, 35.6, okay? Approximately. Okay, so just multiplying by 0.75, and I've got a pretty good table. Okay, it asks about the independent and the dependent variables here. Now, I kind of set this up on purpose this way, so it was kind of a natural transition. The bounce height is going to be my dependent variable, okay? And it's going to depend on the bounce number, because the more bounces I have, the longer it's been since I've had that initial energy act on the ball, that initial drop of 200 meters, right? However high up it bounces is going to be based on, the rebound is going to be based on however high up it bounces. And the more times it's bounced, the less that height is going to be. So that's why my bounce number is going to be my independent variable, or x, and my rebound height is going to be, H-E-I-G-H-T, is going to be my my dependent variable, my y. Okay, and you can kind of see that I set that up in my table. It's very common in tables to have x's be the first row and y's be the second row. So there was some thought that I put into that. Part D is going to now allow us to maybe look at our quick sketch from A and formalize that a little bit more formally in a graph here. And I set this graph up ahead of time, and this I don't think is going to be anything too crazy for you. But let's just go ahead and start. We had at Mount Zero, we had a height of 200 centimeters. Okay. And then I'm going to go ahead and I'm going to graph my other points. Bounce 1 was 150. Okay. And then bounce 2, I got to scroll up again, is 112.5. Now this is where this might get a little tough for some of us. I can't graph 112.5. I just can't be that accurate. So I'm going to do my best here. 2, I know that's going to be in between 110 and 120. It's going to be a little closer to 110. That looks pretty good for me. Okay. And then I got 84.375. I can't do that. That's pretty close to 85. So that's like halfway in between 80 and 90. All right. And then I've got 63.3. Okay. So I'll go over to 4, go up to 63.3. That's going to be a little less than 65. So I'm trying my best there. All right. 47.5. Okay, so 47 point, that's pretty close to 50, but it's not quite there. And then the last one was 30, that's almost 36. 35.6 is almost 36, a little more than 35, should be pretty close. Okay, so right in there. Now, ladies and gents, first thing I want you to notice, and again, tying back to our knowledge from yesterday or our last lesson, I cannot take and connect all these dots with a straight line, as evidenced by my green line there. I could, and this is going to be a long sweeping one, I could connect these with a curve. Now, I'm not going to connect them, and I'll explain why in just a minute, but what I want you to see is we have that bouncy ball height kind of creating that curved data, and there was method to my madness there, and we can kind of see that right there. Now, obviously, Anderson's sketch isn't as good as the graph, but hopefully we could start to see that emerge in our graph. But here we go. We got our graph. It's giving us that, ready for this, exponential shape, that curve shape, that exponential decay shape. This is not a growth one because we're going down over time as the number of bounces continue. But the last part here, and this is the part I said I would explain, it says, should the points on your graph be connected? And I didn't connect them, right? I had the green line on there. I didn't connect them. And the reason I didn't is because I can't have a partial bounce number. I can't have a partial fraction of a bounce. There's either going to be 1 bounces or 2 bounces, and I'm not going to have a number in between. So what we call this is a discrete measurement. We call this discrete data, which is why my graph is just going to be made up of these points and not a smooth, continuous curve. Okay, so I'm throwing a little bit of language at you there that might help with some understanding. Those are words we've used before and maybe you've heard before from some other classes. But like I said, I am trying to throw some of that language like exponential decay your way. Ladies and gentlemen, last little bit of work here from section 5.1. This comes out of 5.1.3. There are 1, 2, 3, 4 review preview questions here. And remember, we talk about the importance of review preview because they help us formalize some of those questions and help us give ourselves a very good idea of what some of those things we can ask are to seek and take ownership of some of our understanding. Ladies and gents, thanks for watching. Have a great day.